So, with this video, I will show you how a fuel cell stack is made. The operation I will do is to take apart the fuel cell to add two more cells to the stack. 1, 2, the cells are waiting there. That will give you the occasion to see how it is designed inside. First of all, this fuel cell has been designed for research and professional training. This one, for example, is composed of 5 single cells. 1, 2, 3, 4, 5. And the first specificity of this stack is that the bipolar plates separating two cells are made of 2 half plates with liquid cooling flowing inside. And cooling fluid is also flowing at the end plates, here and here. That is made to ensure the best thermal homogeneity within the whole stack. The general arrangement of the stack is very conventional, with on one side the inlet and outlet of the anode gas flow, with the inlet of the water or liquid cooling, and on the other side the inlet and outlet of the cathode gas flow and the outlet of the liquid cooling. I have more rooms here available on the tie rod to add more cells, and I'll start by untightening all the nuts to take apart the compression plate and the current collector here. I will start to take this out, and then I will access the graphite plates. So, as you can see, I have taken the washers and the bolts out, and now we'll take the compression plate out. And to do this, there is a small gap here, and I will simply use a flat screwdriver. By inserting the tip of the screwdriver, I can use it as a lever to push the plate out, because the gaskets are a little bit sticky, so I just cannot pull it out like this. I will really need to separate it with a tool between the current collector and the plate. So I will do it now. And there, it's out. So I can now take the plate out. There it goes. The compression plate is out. And it goes off very easily. There, that's the current collector for the gasket. So you can see there is still water inside, because this fuel cell stack has been run lately, so still some water in. Okay, just having a look at the first cell behind the collector. You can see there is a channel right behind the current collector, and this channel is the liquid cooling flowing at the end plate. One detail here, you can see that the graphite plates are insulated from the tie rods to avoid short-circuiting all the plates, and the insulation is made by plastic tubes around the tie rods. Now we will add 2 cells, the cells that are waiting there at the cell itself. So that's the components required for a single cell. 1 cell, 2 graphite plates, and 1 membrane electrode assembly. So what you can see here is the gas diffusion layers and the subgasket used to support the electrolytic membrane. The plates, if you have a closer look, are equipped with a gasket, again in single piece of gasket, gas distribution channel. It is here a multiple serpentine flow field, and holes to feed the gas, and here in the middle holes to feed the liquid cooling. So if I return the plate, you can see here that this hole is connected through the plate to this gas channel here. So the fluid, the gas flowing here will go there and flow through the flow field and exit here and go in this hole. So basically how it is made is very simple. One plate with distribution channel, one MEA placed here like this, and in front of this another plate like this, and you have like this one cell. So you can see here, for instance, one cell that is ready to be assembled with the membrane electrode assembly inside. So now we will add this cell to the rest of the stack. I will first take this plate, taking out the gasket here. I will start with this plate because it is flush. If we have a closer look at the stack, you can see that the cooling channels is already on the back of this graphite plate. So the gasket is here, the cooling channel is here, so I will place this plate flush, and it should go nicely around the tie rods there. There it goes. Okay, one plate, the gasket. Never forget the gasket, otherwise of course it will not be gas tight at the end. Now I will place the membrane electrode assembly. These MEAs are symmetric, so the anode is exactly the same as the cathode, so I can place either side, it doesn't really matter. There, the membrane electrode assembly is in place. And now there is the second plate to place on top. I can place the gasket first, which is quite obvious because I just place it in front of the other gasket. I can see through the sub-gaskets of the membrane. Like this. And I'm placing the plate through the tie rods. There, and the gasket is placing itself in the plate. I will now move to the second cell I want to add to the stack. This cell, as you have seen before, is ready with the MEA inside, and this cell is equipped with cooling channel on both sides, as can be seen here. For a simple reason, this cell is flush, so one cooling channel between the two half plates here, and because it will be the last cell in the stack, there is also a cooling channel at the outer side of the cell. Placing it again is not very difficult. There it goes. Fairly easy to do. Now what I need is again the current collector. I will place it back here like this. There, it goes nicely in place. There. Now all I have to do is place the nuts and washers back again and tighten it with a torque screwdriver so I can calibrate exactly the force I want to apply to the different cells. I have finished tightening the bolts, and now we have a stack of 7 cells instead of 5. If you want more information about this product, you can go to our website. Thank you for watching.